Hey everyone, welcome to today's webcast on Databricks for Engineering. My name's John Ward, I'm a Principal Consultant with Thorogood, and I'm joined today by my colleague Robbie Shaw. We've both been recently involved in developing solutions that utilise the power of Databricks. Before we get into Databricks detail, I'll just give a quick overview of Thorogood for those of you not familiar with us. We're an independent business intelligence and analytics specialist consultancy with operations in the UK, US, India, Brazil, and Singapore. Our core business is the design and development of business intelligence and analytics applications, but we also provide a full range of services, including strategies and roadmaps, training and user adoption, and support and data services. Thorogood works with a wide range of tools and technologies. We're a Databricks partner, and it has become an increasingly important partnership as many of our clients are moving to an AWS or Azure cloud architecture, and Databricks integrates with both platforms. Today, we're going to be showing Databricks in the Azure platform. And the relationship between Azure and Databricks is particularly interesting because of how closely Microsoft and Databricks are working to align the technologies. But most of what we go through today will be equally applicable to AWS. Okay, enough about Thorogood. We'll now delve into the Databricks content. For those of you who didn't join part one of this series, focusing on Databricks for data science, we'll have a short recap covering an initial overview of Databricks. We'll then spend some time looking at how Databricks is used for data transformations and show a simple demo before moving on to an overview of Delta Lake for Databricks. I'll hand over now to Robbie, who's going to give a quick introduction to Databricks.
I'll try to make this introduction brief, so those who watch Databricks for Data Science, the first part of this two-part series, aren't hearing the same thing twice. What is Databricks? It was created by the team who founded Spark, and is essentially Spark extended to an enterprise-ready tool. It's integrated with Azure and AWS cloud platforms. Spark uses a cluster of computers. Databricks automates the setup of these computers and handles auto-scaling, making sure you only pay for the computing power you're actually using. This means big savings, particularly when a lot of computing power is required for a short period of time. Databricks uses notebooks, which are broken up into command cells. These allow for incredible flexibility as Databricks supports a number of different languages. Therefore, each cell may use the most appropriate language for the job. Many of the most popular machine learning frameworks are built in, and finally, Databricks has enterprise-level security built in. Databricks has quickly risen in popularity, and it recently came 13th on Forbes' Cloud 100 list because of the features mentioned in the last slide, and more importantly, how they can be applied. We see two main applications of the technology. The first application is for data engineering and ETL at scale, particularly with more companies embracing cloud architecture. Databricks is offering the flexibility and capability that these businesses need. It connects to a variety of data sources and data types for input and output. There's multiple languages and multiple Python libraries available to transform the data. Plus, the auto-scale functionality lends itself excellently to regular data loads where lots of power is required for a short period of time. Remember, you aren't paying for that power outside of these bursts of activity. Databricks also has great performance compared to more traditional data engineering and ETL tools. It uses in-memory computation for transformations, and it can run loads and transformations in parallel by distributing the workload across different nodes. The second application we see is for data science, and again, it's the flexibility that comes to the fore. It's very useful to be able to switch between languages and use whichever machine learning framework you wish to approach your business question with. Additionally, the user can display their analysis in a very readable format, as they can explain steps with text and headers, and they can divide the notebook into collapsible sections. This allows for easier understanding and easier developer collaboration. Now, just to give some context before we go into any demos, I'll give a quick rundown of the components we'll see. AWS or Azure will set up the Databricks workspace, but the workspace itself will be on Databricks Online. All the coding and data storage occurs within the tool. Within the Databricks workspace, we need a cluster and a notebook. The cluster is one main computer called the driver node, and several other computers called worker nodes. The driver interprets the run commands, and the actual processing workload is distributed across worker nodes. The cluster is easy to set up, and clusters differentiate by size of machines and number of machines. The notebook is made up of cells of code, and each cell has its own output. The notebook may be run as a whole, with each cell running in sequence, or individual cells may be run. That should give us enough of a background to continue, so I'll hand back to John for our first demo.
So yes, in this demo, this diagram here shows an example of where Databricks may fit into an end-to-end cloud architecture. You typically expect to load data from multiple data sources into a data lake, And this is often orchestrated as a straight copy of raw source data using a tool such as Azure Data Factory. The power of Databricks then is to be used for transforming and enriching the data to optimize it for business use. In our demo, we'll show how you can use different languages flexibly to carry out rapid data loading and transformation within the data lake. More often than not, you'll want to load the enriched data into some sort of semantic layer, such as a SQL database to make it easier for reporting tools, such as Tableau and Power BI to connect to data. This can be done within Databricks itself, but in this scenario, I will do all the transformation work within Databricks and create a final set of data as files within the data lake, and then use Azure Data Factory to carry out a simple copy into SQL. Start by looking at the data in our data lake. So the data lake storage that we're using here is effectively like a file system. And in my raw folder, I have this retail sales folder that contains some data simply replicated from a data source. In this demo, we're using a simple data set of sales and the associated product, store, and time dimensions. The sales file contains around 1 million records, and you can see that it's a 35 meg file. So it's not a huge file, but it's not a trivial example either. So what we want to do now is use Databricks to load this data, transform it into a way that we're going to use for reporting, and output back to the data lake. So this is Databricks. This is my Databricks interface, and this is a Databricks notebook. And you'll see pretty quickly it's very code-based. You can add in comments and titles, as we've done here, to lay the code out effectively. And each command can be laid out in its own cell to better manage the code. You'll see in the top here that I've set up this notebook to default to using Python, but we can use other languages within the notebook as well. But these first few steps use Python code. The first step I have here is to create what's called widgets, which are to collect parameter values. You'll see at the top here that I've put 2 parameters in this that drive this notebook. One for the source path of where I'm fetching my data from in the data lake, and one for where I want to write it out to. So I could run the entire script, or I can run individual cells as I just did. So in this next step, don't worry too much about the detail of the code, but effectively what I'm doing here is reading a CS file into a Spark data frame. So this is my time data, and I'm going to load this data into memory from my time file. So once I've done that, I can then look at the schema of what's been loaded. Because I haven't inferred the schema from the source file, all the columns have defaulted to string. So instead of doing that, I'm going to load the files in and get the schema inferred from the source file. And actually, I'm going to loop around the 4 files I just showed you in the data lake storage and load those in. Okay, that's run. I can now look at my time schema, and you'll see it's now picked up, and not just string fields, but actually integers and date times where those data are appropriate. You'll see how quickly those loaded in as well. And if I just double check how many records we've loaded in that sales file by running a count command, you can see we've got just over 1 million records, as I said, loaded in very quickly. And as Robbie said, that's really because it can distribute activity across lots of worker nodes and load a lot of stuff in parallel. Let's have a look now at my product data. So I can select the data from my product data frame. And you see this data set is around sales of products from a confectionery and biscuit company. Now, if you look at this data, you can see that I've got some null values in here. I've got some blanks in my data. That's pretty valid, but not very useful in my reporting tool. So I'd like to do some simple transformation to replace any null values with not applicable. I'm going to run this transformation as a Python script. And now, when I look at the product data, you'll see now that all those nulls have been replaced by NAs because of my code to replace the nulls. So a pretty simple transformation done in Python. What I want to do now is slightly more complicated transformations and more suited to being done in SQL. Also, I'm more familiar with doing transformations in SQL. I'm going to take all of my data that I've loaded and convert to SQL tables, and then I can start writing SQL. So in this example, I'm going to write a view that combines my sales data with my stores, products, and time dimensions, and creates a denormalized table that may perform better in some reporting tools, for example, in Tableau. Notice the beginning of this cell, I put %SQL, which indicates to Databricks that I'm changing language to use SQL, and I can run that to create that view. So having carried out these transformations, and I now have a table in Databricks of the data in the format I want, I'm going to write this data out to my enriched folder in the data lake. I can write this data out as a single file, or can partition the data for more optimal usage. In this example, I'm going to partition by week. I'm also writing this data out in a file format called Parquet, rather than as a CSV. I could write it as a CSV, But Parquet file format is far more optimized file format for data lake storage and is pretty commonly used these days. You'll also see that I've got some print commands in here, so that when I run the command, as I've just done, it writes out some of the statements I'm building as I go, so I can see some track of my of what's running through my code and if there's any issues, why it would have gone wrong. So that's run. I'm going to switch back to my data lake now, and I'm going to look in my enrich folder. So within retail sales, you'll see now that I've got data that's been created. The success flag is a bit of an information file saying that ran 3:15 UK time, so it's just run. And I've got a partition by each week. If I look inside the week file again, I've got some information files telling me what was run when. And I've got this Parquet file that I just talked about. It's all a little bit untidy. So the last step in my notebook, I'm going to actually run some code to rename those files to something more sensible and remove the information files that I don't really need. So this is again using a different Python library to manipulate files in a file system. If I switch back now to, I'll go back up directory, see that information file's removed, and going into the file, I've now got a neater Parquet file. You can also see that each file is just over 200K. So overall here we have just over 1 meg of data in Parquet format, compared to 35 meg of data that was in the original CSV format. So it's a pretty simple example, but hopefully it's demonstrated the flexibility in being able to easily switch between different languages, such as Python and SQL, and the speed at which data can be loaded and transformed through the data lake. You see, in a matter of seconds, really, being able to load in that million rows of data, combine with other data sets, carry out some transformations, and write back to another separate file. It's also hopefully shown some aspects of working with the Databricks interface, which I really love. The ability to easily run parts of code, test what you're running, see what's being output as you run. And one last aspect to show you quickly here is the revision history. I have the ability here to actually go back to older versions and it will track everything I've been doing when I've been changing this notebook. I'm going to now quickly show one last thing, which is the integration with Azure. So this is Azure Data Factory, which I tend to use for orchestration and simple data movement. You can see here that Databricks notebooks can be called from ADF. Here, I've developed a simple pipeline that calls the Databricks notebook I've just shown you to carry out the data transformation, and then copies the data from the output files into a SQL database, ready for reporting. I can set up parameters in this pipeline. I've got some here for the notebook name and the source and destination file. And these can be passed into the notebook. You can see these parameters can be passed into the notebook here. So when I run this, prompt with the parameters, and that will go into the notebook and drive those parameters that I set up in the notebook to drive the code. And this parameterization and integration with ADF allows for really being able to flexibly change settings in the future without having to rewrite code. And it also allows for the reusability of notebooks for different variables. You can see down here, I can track progress as this is running. I can see what input parameters were passed into the notebook. I can actually go and view the notebook as it's running. So this is a really nice feature. So this shows the current run of the version of the notebook I've just shown. At the top, it shows you which parameters have been passed in. And then I can scroll down and actually see on each cell how long it's taken, whether it's run, and for some of the cells where I put in comments and outputs, you can see it's showing me what it's run as it's gone through. So that looks like it's all run. So I switch back to Azure Data Factory. I'll just refresh this. You see that run? It ran, took about 58 seconds. It's a bit slower when running for ADF, you have to connect and then run, but it took about 58 seconds in total for carrying out that load of the 4 source files, including the million sales records, carrying out the transformations, and then creating the output files. The next step that's now running is the load of that data to SQL, and that's succeeded as well. That's the end of this demo, so I'll hand back now to Robbie, who's going to have a look at Delta Lake.
Most data engineering solutions completed using Databricks should probably now include Delta Lake. In the next few slides, we'll explain what it is, why it's recommended, and then demo it. So what is Delta Lake? Delta Lake is a storage layer, and its main purpose is to bring more reliability to data lakes. The data itself is stored as versioned files in Parquet format, which is useful as this format works with a vast range of tools. We see its unique selling points as assured data integrity with ACID transactions. ACID is atomicity, consistency, isolation, and durability. You can trust you have a valid version of the whole data, which will be unaffected by concurrent executions and system failures. Scalable metadata handling. This guarantees that no matter the size of the metadata table, it will be processed easily. Schema is easily enforceable with Delta Lake. Therefore, there's no concern over the data structure or format. For instance, if you try to append data with an incorrect schema, it will throw an error. It will also deal with missing information, such as applying the current partition to any appending data. Unified batch and streaming means that you can be sure a table in Delta Lake is always the most up-to-date data, as Delta Lake handles both batch and streaming sources of data. And finally, audit history, time travel tracking. This feature has many names, but basically it allows you to check on the changes that have been made to data and select older versions of the data. This feature will be on show in the demo. Delta Lake was first offered just in Databricks, but in April of this year it was rolled out as an open source project. Despite this, Databricks is still the best performing tool for employing Data Lake. Now, let's see the tool in action. It will be another data movement and transformation example, but in this case it will utilize Delta Lake and its accompanying features. The diagram roughly illustrates how the data will move in the demo. First, the notebook will establish a connection to an Azure SQL database. It will then read the data from the table in the database into a Spark data frame. Next, the data will be saved to a Delta Lake location. Transformation will be applied using SQL language, and the resulting data will be written out to the Azure Data Lake. So if I open the notebook here, so as you can see, I've already run the first two commands. Databricks tells you when the last cell was run and who it was ran by. The first command created widgets. In this case, I provided values for the widgets at the top of the notebook. In a full cloud solution, the values will be passed into the notebook, just as John said. The second command establishes connection to the SQL database. Both of these commands make use of Databricks utilities. These are the dbutils.widgets and dbutils.secrets. These utilities perform combinations of tasks that are particularly useful within Databricks. And as my next command, read the data from the table into a Spark data frame using the widgets and connection I've established earlier. This to a Spark data frame to the pre-specified Delta Lake location with partitioning by region. I then create a table using this Delta location. And Delta Lake has a couple of optimization options available. They aren't required in this case due to the size of the data, but I've given examples of the options anyway. This Databricks file system utilities function allows me to see the files in the sales folder. So you can see it's Delta sales and all the partitions by region. The next two commands, detail and formatted, give me information about my new table. Detail shows me some metadata, and formatted shows me the data types. Now, let's look at the data that's actually been loaded through. As you can see, I've switched the cell to SQL language in this case. And once it comes through, you can see that it's similar data, it's sales data of suite items, including some time and geography information. I'd like to focus on the category column. Notice that there is only confectionery in this case. And if I run, I can delete from sales where category equals confectionery. If I run then this describe history command, I can see the changes that have been made to the data. So you can see there's a write case here, which was my original write-in, then the one I just did there, and the delete function. And if I go further down, you can then select certain versions of these data. See here, I can display the initial version of the data, which includes confectionery and biscuits. And here is an example where I might have made a few changes, but actually want to see the data from 15 minutes ago, maybe without these changes. And that's using this timestamp as of this timestamp, which was 15 minutes ago. If I want to see the difference between tables, so if I want to see the difference, say, I imagine this example would be, I return to a collaborative notebook, and I find someone else has made changes, and I want to see what they've removed. I can use this accept all function to see the changes that have been made. By the way, this @v1 and @v2 is just an abbreviation of version as of. And if I run that, you can see the difference between the two tables. And you might be thinking, although this version history is useful, surely the versions eventually become more trouble to store than they're worth. This is where the vacuum function comes into play. You can set the number of hours you wish to retain old versions. In this case, I'm keeping old versions for 10 days. And once versions have become older than 10 days, they'll be deleted. And finally, I'll write out this data using similar code to John, just to write it out to a layer in the data lake. and it's partitioned by region in this case. I hope you've gained some insight into Data Lake from that, and I'll pass back to John to talk about how you can get started with Databricks.
So, how could you go about getting started with Databricks? We'd be happy to help you get up and running. We can help to understand your key use cases and how Databricks could be used to enhance your solutions, maybe via an initial POC. We can help you set up Databricks and other cloud capabilities as needed. We can show you how to use Databricks as the main tool for data transformation in your end-to-end data flows, and how it could improve the agility and performance of your solutions. And we can help with how you deploy Databricks, whether you're using Azure or AWS. So if you're interested in getting help starting with Databricks, or would just like an informal discussion on this topic, then please feel free to contact me directly. My email address is shown here, john.ward@thorogood.com. Before we finish, Robbie mentioned earlier there was a part 1 to this series exploring Databricks for data science. If you missed that, then I'd encourage you to catch up. It's available on our website on the perspectives page, www.thorogood.com/perspectives. That concludes our webcast. Thank you.